Okay, so you guys, need you to stop talking. I know you're so intrigued in this subject that you want to talk to others. But whatever, let's just reel it in and talk about this. Does anyone know what this is called, that plus or minus 3%? It has a vocab word that maybe you've heard of before. Anyone else?
Probably heard it, but I don't know.
It's called your margin
Oh,
of error. Have you heard of margin of error before?
yeah, it's when they say, I'm sure, but if in case I'm not,
It gives you a little wiggle room, right?
57%, give or take 50%.
Then you've definitely covered your bases. We're going to talk about it. Give or take. I like that. It's give or take a little bit. So here's the idea, guys, is when we want to know the presidential approval rating, who is our population? Who do we want to know if they approve of this rating?
Us.
It's going to be USA adults, right? People who could vote, right, for it. So they're going to randomly select people and look at what proportion of them approve of his rating. Now, why do they need to randomly select people when they're doing these samples?
So they don't have a bias.
There we go. So if we randomly select them, then we're hopefully going to eliminate a bias. However, does that mean our data is going to match up exactly? No, so when we take our sample proportion, it's P with a hat on it, okay? It's called our sample proportion. And we have our population proportion, but the only way we would find that out is by asking everyone. And that would take way too long, right? Cost way too much money. So instead what we do is we take a sample proportion, and then we say, hey, this is pretty close. There's just going to be a little give or take, a little margin of error. So when I'm looking at President Biden's approval rating, what is the highest it could be?
60.
It could be plus that 3. So if I did 57% plus 3, that takes it to as high as 60. But if I did a 57 minus 3, it could be as low as 54. So what we have created right here, this is called a confidence interval. Have you heard of a confidence interval before? In statistics, this is one of our most common types of inference. Inference is when we infer or assume something about the population based on a sample. And since we are doing a random sample here, we can infer our sample data to the population, but there is going to be a little bit of margin of error, a little wiggle room. So this gives us a range of values. We say, I don't know exactly which one he is, but it's somewhere between 54 and 60. Now, is that narrow enough that it gives us pretty good data?
Yeah.
Yeah. Could we say that the majority of Americans approve of his job?
Yes.
Or is it more than 50? For sure. But could they say it's more than like 65%? No, we know it's somewhere between 54 and 60, right? And granted, that could change week to week, and that's why they are continuously surveying people. All right, that is your introduction to margin of error and confidence interval. Today, we are going to do 2 of those and get to your assignment where you're going to do more of them. Before we do that, though, let's just kind of talk in general about what we just did. Here's some other stuff. We're going to skip that. Okay, so today, we're going to calculate confidence intervals for sample means and sample proportions. Now, under here, population and sample, it's basically that picture I just drew. Is in statistics, we have our population, and there's something about the population we want to know. Yeah? Yes. Is it not recording?
It's sort of it's blinking.
Okay, I think I pushed the record button. Thanks for checking on me, though. So in our population, there's a parameter. It's something we want to know. Let's call that our population proportion. How about that? But again, if we talk to everyone, we call that a census. It takes too long. So what we do instead is we take a sample. And from that sample, we can get a statistic. that's a characteristic of our sample. So let's say Antonio has just written this song, he just went to the studio, he recorded it, and he wants to know what people think about it, okay? So he can't play it for everybody, or maybe he could at the Spirit Assembly, or the Multicultural Assembly next year, right? But for this year, he's like, I'm just going to choose a sample, and I'm going to see, based on that sample, how many people like it. What proportion of them like it? Now, does that mean the whole population will feel that same way? Not necessarily, but he could get a confidence interval by doing the margin of error, giving him some wiggle room and say, well, if this proportion liked it in my sample, then I anticipate it'll be similar to that with a little wiggle room, okay? And what we're going to talk about is how we get that little bit of wiggle room, how we calculate that margin of error. Now, to introduce that, let's just talk about a game. How many of you guys have ever been to Lagoon and walked past that game where they say, hey, pay me some money, if I get your birthday wrong, you get a prize. And then if I get your birthday right, then you don't get a prize. You ever seen that game? So last summer I decided I was going to do it. So I even set it up where I shaved and tried to make me look as young as possible. And I paid them $5 or whatever it was, and they guessed my age, and they totally guessed too young. So I got an inflatable corgi. You know what a corgi is? It's that kind of fat dog. Yeah, it's awesome. And if you push the nose, it squeaks. And I was like, oh, that's fun, until my kids did it a million times, and I'm like, I'm going to, like, kill that corgi. Okay? All right.
How young did they guess?
Well, I can't tell you because we're not going to actually play this game, but let's talk about it. Let's say I wanted to give you guys a challenge, and I said, I want you to guess my birthday. Not just how old I am, guess my birthday. Now, here's the thing, is you can choose between one of these three options. You can guess with a 2-year interval. So you can say, I think it's January 1st of this year to January 1st of 2 years later from there. So you have 2-year interval. But for that one, you only get a small prize. If you guess the second option, where you only get a 1-year interval, if you get it right, you get a medium prize. But if you guess within just a 6-month interval, you get a large prize. Now, which one of those do you think you would feel the most confident in?
The small.
How come, Mindy?
Because it's the easiest to guess.
Yeah, when you have 2 years to guess, you've got a bigger window, right? And so it can kind of like cover more ground. So since it's easier, that's why you just get a small prize, right? The medium one, instead of being so wide, it's a little smaller. But you still got a year, right? So maybe you're closer. But this one, if it's a very small interval, it'd be very accurate, right? But then what's the challenge there?
It's way hard.
That'd be hard to do. So if I said, hey guys, guess it, which one would you choose, a small, medium, or large?
Large.
Go big or go home?
Yep.
That's Mindy style. It's funny because I've done this before. I had people guess it, and they're like, well, when were you born? I'm like, I'm not going to tell you, then you can figure it out.
What's your personal email?
When you graduate, they look on Facebook. I'm like, I don't put it on Facebook. Boom. All right. So anyway, the idea that we're trying to make here, guys, is with our confidence interval, we want it to be small enough that it's accurate, but also wide enough that it's, we want it small enough that it's useful. So if I told you my birthday is sometime between January of 1960 and January of 2010.
At least I know you're not like super old.
Then it's like, well, we know you're at least 11, but you could be as old as like 71 or something like that, right?
Yeah.
That's not very helpful. So you want it to be small enough that it's helpful, but also we want it to be accurate. So we need it to be wide enough that it's accurate. So how big do we make this margin of error? Well, most of the time, what we're going to do is just go out about 2 standard deviations. Because do you remember what our 3 magic numbers are? If I start from our mean, what's 1 standard deviation cover?
68.
68. What's 2?
95.
95, and 3 is?
99.7.
All right, so now, mathematicians were like, hey, if I'm right 95% of the time, is that pretty good? I think of maybe like my relationship with my family and my wife, and I'm like, am I right 95% of the time? If only, right? That would be amazing in a relationship to be right 95% of the time.
You're only right like half, maybe less.
I'm not, yeah, my wife is right basically all the time. She's in that 95%, and then I'm whatever. But the point is here, is being right 95% of the time pretty good?
Yeah.
So what we're going to say is with our margin of error, we're going to say, we're going to make it wide enough that we're right 95% of the time. Well, how many standard deviations do I have to go out to get 95% of the data if it's normal? 2, because we went 68, 95, 99.7. Well, when we were doing that, those were approximations, okay? If we want to get exactly 95, it's actually a little bit less than 2, it's 1.96.
What?
Is
You
that
lied
essentially?
to us?
I did. Trust is gone.
Oh.
So it's not 2, it's 1.96. But the idea is if we go out 1.96 standard deviations from the mean, we've got 95% of the data.
Can't believe this.
So how often will we be wrong?
Less.
5% of the time.
That's
Which
how-
is pretty good, okay? In stats, that's our kind of rule of thumb, is if it's less than 5%, that's pretty rare, so we like it. Now, this relates to this Garfield comic. Garfield's watching the TV and he says, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. Garfield says, this guy's never wrong. Why is the guy never wrong?
Because that's all the temperatures.
Yeah, right? These are temperatures that we will never reach on planet Earth, right?
I don't know.
Well,
I've seen
40
that.
below
I've seen
zero, I'm sure
negative
that's happened,
41
but
degrees.
has 200 ever happened?
I don't know. Maybe in Texas they reach 200
Maybe in
degrees.
But the idea is our temperature going to be between 40 below zero and 200 above? Yeah, but that's so wide it's not even helpful. Okay, so what we're going to do, guys, is we're going to say that with our confidence, our margin of error, we want to go out 1.96 standard deviations from the mean. Okay, now, we're going to do a couple examples of this. Since our class is a little bit smaller, we're just going to say heights of students at Hunter, right? I know men and women grow at different rates and heights or whatever, but we're just going to do this. Everyone is going to tell me their height in inches. Now, as a clue, how many inches is 5 feet?
60.
5 times 12 is 60. So if you are 5'4", how many inches is that?
64 inches.
If you are 5'10", how many inches is that?
70 inches.
You got that? Does everyone know how tall they are? Okay, we're going to go around. You're going to tell me your height. So Mindy, what is your height?
64.
64. Okay, Melissa. 62. Skylar. Isaac. 6 foot exactly, huh? Eleanor.
61.
Okay. Ryan. Antonio. Eric. Or not Eric, I'm sorry. David. Emma? Or Emily?
I don't know what 5 is.
It'd just be
63.
63. Jade? Emma? Thanks, Braylon. And then Nellie. Okay, now, what we need to know is it, so what, let me back up a little bit. You said 63, right? Let's say we wanted to know the heights of the average height of all Hunter High School students, okay? Now, we're going to take a sample. Was this a very good sample?
No.
What type of sample did we just do?
Convenience.
Convenience. And why is this sample biased?
Because it's only
you
one.
have like
It's just that's juniors. Some freshmen could be shorter.
Yep.
Some seniors could be taller.
So this isn't very good, but it's what we got, right? So we're going to go with it, okay? Now, what we want to do is come up with a confidence interval that will help us figure out what is the average height of students at Hunter. So we're trying to figure out the average height of students at Hunter. So we're going to take a sample and find its mean and standard deviation. Now, have I shown you how you can put this data in and quick get the mean and standard deviation?
Yes.
We're going to go into stat, edit.
You showed us on the Desmos.
Oh yeah, let's do Desmos. Okay,
Well,
wait, no, we don't have
the
internet.
internet.
JK, so what
Wait,
I'm going to
that's
do,
what you showed us, Desmos.
I'm going to just put this in real quick. So 64, 62, 60, 72, 61, 65, 65, 70, 72, 63, 67, 68, 67, 63. Awesome. Is that 14? 2, 4, 6, 8, 10, 12, 14. Great. So now I'm going to use my calculator. And what I found was that our sample mean here was 65.6. And our standard deviation is 3.9. Now, mean is pretty easy. That just means average. What does standard deviation tell us?
They tell us, is it the lowest?
It's the average distance
Oh.
from your mean. So the standard deviation tells us how spread out we are. On average, we're about 3.9 inches away from the mean of 65.6. Now, here's how we're going to do our confidence interval, okay? When we're working with means, which is what we're doing here, it's going to look like this. We're going to do x bar plus or minus 1.96, and then we're going to do our standard deviation over the square root of n. Now, n is just our sample size, which in this case we have 14 people in this class. And I've already taken the mean and standard deviation, so we're just going to plug it into that formula, which you will never memorize. You're just going to plug it in and use your notes on your quiz, okay? So, what did we say our mean height was for this class? 65.6. Now, where did that 1.96 come from? Remember, we want to be right 95% of the time. So if we want to do that, we have to go out almost 2 standard deviations. Last time I told you it was 2. This time I'm telling you it's a little bit less than 2. It's 1.96. Now we're going to take the 3.9, that's our sample standard deviation, and divide it by the square root of 14. In AP Stats, we go into more depth about where these formulas come from and what they mean, but for this class, we're not going. Okay, now here is where I am going to go into my calculator and put this in. Will you guys all do that with me? You all have a calculator, or use a calculator on your phone? Do 1.96 times it by 3.9, and then divide that by 14. And once you have that, check with your neighbor, did they get the same number that you did? I got 2.04.
Is it the square root of 14 or just
Yeah,
14?
14.
You said 14. I put in just 14. I was
Oh.
like, that doesn't sound right.
So, can I show you on my other calculator that you guys can actually see? Oh, well, I had it up and then...
2.04.
You got 2.04? Will you
Yeah.
guys check with your neighbors, did they get 2.04 as well?
Do you have internet?
I don't think so. Nope.
What?
So, what that means, guys, this 2.04, what do we call that? That's my wiggle room. What do we call that?
Margin of error.
Good. This is our margin of error. So what that means is, just like with the President Biden example, we are going to add that onto our mean and subtract it off of the mean. So I'm going to come and say, alright, so our upper bound, our top spot is going to be 65.6 plus 2.04. And then we're going to do 65.6 minus 2.04. If if I add those together, I get 67.64 is the highest it could be. And if I subtract it, I get 63.56 is the lowest. And this is my confidence interval. Okay, now did you guys get the same numbers when you did this on your calculator?
Yeah.
So based off of our sample, which admittedly is biased, but whatever, we would say that we are 95% confident that the average height of students at Hunter is between these two numbers. So it could be from 60, that'd be 5'3" to 5'7". Now that's going to be
95
male and female. Okay?
95% of us are in that number.
No, so what that means is that if we were to do different samples from Hunter and do it over and over and over and over again, then in about 95% of those, they would be accurate. They would
Oh.
have the true value in there. But for 5%, they would miss it. And you'll see more of what I mean by that when we do our next set. Okay, so does this make sense so far? On your homework, basically I'm going to give you the values that you plug in, and then you just work it out. You don't have to worry about like memorizing formulas and things like that. Now for this next activity, we're going to change from looking at proportions, or sorry, we're going to change from looking at means to looking at proportions. Before we do, is there anyone here who's allergic to chocolate?
What a life to live.
I know. Well, so I do this M&M activity each year, but I think it was 2 or 3 years ago, I had a student who was like, I'm allergic to chocolate. Everyone's going to take a tissue just like flat. And so we had to do it with Skittles instead. But now we're back to using chocolate.
The better
Here
way.
we go. Okay, so what's going to happen is I'm going to come around. Well, okay, so this new question. What colors are in M&Ms, regular M&Ms?
Blue,
Yellow,
red,
brown,
yellow, green.
Okay, now what I'm going to do is I'm going to give each of you a small amount of M&Ms from this bag. So I went to the store and bought a family-sized bag of M&Ms. And I'm mixing it up. And what we want to know is what proportion of these are yellow. It looks like on here they've got green, red,
orange.
blue,
The primaries
orange,
and-
brown.
It's red, orange, yellow.
Primaries and then the
But then,
secondaries.
What
Nope,
percent
not
are
purple.
yellow?
They don't
Okay.
like purple.
These are normal. So what I'm going to do is I'm going to come around each person and pour out a little bit. Now your job is when I pour it, kind of hold your hands in such a way that they don't go flying, okay? So now I come to Eleanor. I'm hoping to give you guys each between about 30 to 50. All right, there we go. Now what she's going to do is she's going to count how many are yellow and how many total there are, okay? So let me back up a little bit so we're all on the same page here. The question we're asking here is what proportion of M&Ms are yellow? So to figure that out, we're going to take a sample proportion. Each of us is going to have different numbers this time, but even then we could still get accurate data. So what you're going to do is you're going to count the number that are yellow, and then divide that by your total. Okay? And write that down. So I'm going to come around each person. Remember to make that U so that I don't spill.
I don't want yellow M&Ms.
Yep.
Do you have any? I got 4. Yellow M&Ms are lacking. This is
Now what's crazy is that some of you are going to get a lot of yellows and some of you are going to get not a lot of yellows.
none. 0 yellows. I ate the one yellow one.
Uh-oh.
Be careful, be quiet in front of the count. There's